A good moment on which to ask Jad if he would now give his second presentation on ballast water management, please.
Thanks again for this opportunity. I will talk now on a completely different topic, and ballast water management is a topic that I've been working with for many years now, following up both technologies and development of rules, both at the IMO and in IACS in class. And I will try to run through a presentation where I just show you a little bit on the international regulations. Where are we at? What's happening? A little bit around that. US, what's happening there for those ships, so those of you that are sending your ships to the US. Also on the technologies. I've put an overview and I will go through them and what's happening. Also examples as I speak about our experiences from especially retrofits, but also new builds. We are delivering in DNV a lot of ships. I would say most of our ships being delivered today are being delivered with a treatment system installed for new builds. Not so many retrofits. We've had examples of fleets being retrofitted up to 20 ships. Those have mainly been offshore supply vessels, but also we've seen tankers being retrofitted and cruise carriers, ro-ros, all types of ships. I'll be happy to go through that as well. On the international regulation, I guess you all updated that it's Denmark has signed recently, and we have the number of states already in place for the convention to enter into force. What's missing is around 6% of the gross tonnage. We know that Germany has announced last month at the MEPC meeting that they will be ratifying anytime soon. And Germany is quite a significant tonnage. If you look at the big picture, we see that those 6 flags on the top here, 7, if we consider China, Hong Kong, they usually sign together. Those are the flags that can kick this in or not. The way it looks, the only flags that are still, we don't know where they stand, at least from our information, is China, Hong Kong, and the Bahamas. The other flags, Panama, Singapore, Greece, Malta, and Cyprus, we don't expect them to sign and kick this in. So that boils it down to 2 major countries that have to sign this. The change in Bahamas that we've seen that's quite interesting actually is that they are now the vice chairman of the MEPC committee, and we've seen a change in their position when it comes to ballast water. Probably that has to do with it. It's just speculations on what Bahamas would do. China, Hong Kong, we don't know what they would do when it comes to signature on the convention. When the convention is signed, you have 12 months and then it enters into force, and then new ships have to have a treatment system on board. Old ships have to be retrofitted according to a certain timeline. I will come a little bit to the timeline. I've put a small slide on that. This is the way the regulations look today. You have for ships that are less than 1,500 and more than 5,000 cubes of ballast water, you have until the first intermediate or renewal after the anniversary date in 2016. And that so stretches the dates of retrofit of a treatment system between 2017 and up to 2020. For the ships falling in between 1,500 and 5,000 of ballast water capacity, you have the same, but from 2014. So the first intermediate or renewal after 2014, and that's then 3 or 4 years from that, 2015 and up to 2017 or 18. Those are how the regulations are today. In October at the MEPC meeting, it was agreed to have a correspondence group to look into how, because obviously you have tens of thousands of ships that needs to be retrofitted in the period between 2016 and 2020. A group of people now is debating or making a a draft resolution trying to agree on easing this implementation date by removing the intermediate survey requirement from this so that you only have to retrofit at the renewal stage. That's one thing they are looking at. Another thing they are looking at is whether they should consider ships that are built before the entry into force of the convention as existing. Today, 2012 is a deadline. Ships built or key laid as of 1st of January 2012 are required by the conventions to have a treatment system at delivery or when the convention enters into force. What the debate is going on now is whether those ships should also have a 5-year period after 2016. The debate is quite tough. It's two lines. One line is saying that this is not legal because this is a convention that is not entered into force and we are changing it. Another line saying that if it makes it easier for countries to ratify because of this, then we should let it happen. It's better to have something than nothing. My personal opinion is that this will go to the legal committee at the IMO and say if it is legal at all to do this or not. I don't think we know yet. But there is an intention to ease this up. I don't think it will go so much farther than 2020 or 21 to have ships where treatment is required. After those dates, 2020 and 21, I think most of the world's fleet will be required to treat their ballast water. Or at least, to put it politically correct, you cannot discharge untreated water to the sea. You can either discharge to an offshore facility, a barge, to shore, or you have to treat with a type-approved system. Those are the happenings. There was a lot of debate on whether we should change the type approval program for these treatment systems. This was decided not to at the time being because it's a time when the convention is being ratified or not. A big debate is happening on the sampling for port state control. Nothing new is coming up there. We're going to have to debate again in February 2013. We have not seen any major development in how this, the arguments for or against port state sampling is going on. On the national regulations, we see that the Coast Guard has a new rules that came into force in June this year. The Coast Guard's regulation they have nothing to do with the IMO. You just have to comply. Whether the convention is ratified or not. If you come to U.S. waters and you want to discharge ballast water, you have to comply with the regulations. They require treatment, but they also, and exchange for a period of time before treatment is mandatory for all ships. I will come back to that a little bit later. But they also require fouling, rinsing of anchors, the chains. They want a record book. They want you to have a plan on board your ships that you are doing some hull fouling management and also some sediment management. The major issue with the American requirements are that they have to approve your system before you are allowed to use it in U.S. waters. Today, we don't have type-approved systems by the U.S. Coast Guard. They have regulations accepting other type approvals for a small period of time, but that's a 5 years acceptance. We don't have that neither. We don't have systems that are preliminary approved by the Coast Guard yet. So it's a challenge. The American rules are a challenge. Same discharge standards, so no changes there. The implementation date of treatment for the American rules are different than the IMO. If you are building ships that will be key laid after the 1st of December 2013, those ships cannot call U.S. ports without having a U.S. type-approved treatment system on board. And that's very important because we have started actually now into getting requests from Korean shipyards, especially asking for those requirements to be complied with. Those are negotiations for new builds today that will be key laid next year. And so it's important to keep that in mind if you want your ship to be going to the American market. They also require existing tonnage to comply after the first dry dock, 2016, and for ships between 1,500 and 5,000 cubes of ballast water capacity, then it's after the first dry dock after 2014. So if you have ships in this category, and you know you're dry docking in 2014 at some point, you probably should start planning what to do with that. There are solutions. I think what's important is to require manufacturers to obtain the US type approval and not just have the IMO type approval. It's different. You have another regulation in the US called the EPA regulation. It's basically the same, but it's under the vessel general permit. For those of you trading with the US, you're aware of this scheme. The problem with the proposed regulations is that they require an implementation date of treatment according to the IMO. So it's the same country, two different authorities giving two different dates of when you have to put a treatment system, and that's a problem. We hope that the final ruling of the EPA will be that they will follow the same as the Coast Guard, but we're not sure yet. Nothing special with the US states. California is still California. They will not let you discharge dirty water regardless of how you do it. They don't care how you do it, but they just don't want you to do that. They don't have any means to check it so far. That's how. So we don't expect problems from California for the time being, but we don't expect them neither to change their positions when it comes to discharge of dirty water. They don't want to. Nothing special in the EU. We know that they have a marine equipment directive coming up, so it will be a third scheme for those treatment systems to follow. It will come up somewhere in 2013. We expect that. But otherwise, the EU so far will not introduce unilateral actions. They are happy with what's happening with the IMO so far. On the treatment technologies, we will make those slides available to you, so you can get a copy of those. I've put 5 tables of treatment systems and where they are in the process. What I would like to talk about today, for the rest of how much time I still have, 5 minutes maybe. I will try to go through not so much on the manufacturer side, but on the technologies. So if we concentrate on the third column of this table, you will see that you have 3, 4, 5 technologies that are being used mainly. And manufacturers, all they are doing is that picking up a couple of those, putting them together, and making a system. It's not so much, it was innovative in 2006, but today it's not so many new, bright ideas coming up, very few. If we look at the table, you will see that we have filters, and these are standard filters, only that they are huge, very small filtration capacity, self-cleaned. Filters, when they started, and when we started working with this, had a major problem with efficiency and operational problems. They are getting much better. They're doing a lot of R&D and getting attention because of the volume of the ballast water market. So we see an improvement there when it comes to filtration technology. Just to make a point so that a filter does not remove sediments, because I know that this is a recurring question all the time. Sediments are too small for the filters to remove. Filters' main issue is to remove large organisms from the water. So you remove the large organisms, you're left with the small ones, and this is what the other technologies do: UV, electrolysis, all of that. A filter does not remove sediments. They remove the big ones, like the plastic and the big sediments or the particulate matters in the water. But they don't remove the sediments you usually have in your tanks. So you should not expect a major change in the sedimentation in your tank. You still have sediments there, even with a filter. When it comes to UV, it's a standard technology. It needs to be combined with a filter. Simple reason is that large organisms are very hard to kill by UV. They may barely get a tan, so they don't die. You have to kill the small ones with the UV. UV has a problem with when the water gets really dirty. If you know your ships are sailing in river waters, the UV systems will not work. It's too dirty. The light will not go through, so it's nothing special. A very good filter will not work neither in very dirty waters because it will clog, and then it will be back flushing and cleaning itself all the time. And they have a bad tendency, those filters, to pass large organisms when they clog because you squeeze them through. And so you will get dirty water. And so it's important when we retrofit or choose those systems to know where your ships are operating. Electrolysis, it's making a compound, a chemical compound on site and injecting it back in the ballast water. Major problem with electrolysis is water temperature and salinity. Hydrogen. Hydrogen is an extremely explosive gas that's created as a byproduct of an electrolysis process. How to ventilate it, what to do with it, a very big headache, at least for us in DNV. We don't like hydrogen, and we want to make sure we will not blow up the ship. A very small amount of hydrogen is enough to take the whole thing apart. It's a very powerful gas. I will go to ozone is another popular gas to use. Ozone is very efficient for treating water, but it's also very efficient against humans. It's an extremely toxic gas. This is our major problem with ozone. It becomes toxic at 0.1 ppm, and that's nothing. If you just need a small amount in this room, and then people will get really hurt. Again, safety for ozone is an important part. It's so efficient, you can actually, if you put enough of it, you can use it without a filter. So it's a good treatment model if it is applied safely. And that's it. Those are the major ones. You have some chemical injection, very few of those. We have seen new innovations of putting ozone and then immediately doing UV after that. That's enhancing the treatment process. It's giving interesting results. That's the redox system. Mouawad is a new system as well, doing heat treatment. Very interesting. This is the same way we pasteurize the milk today. You heat it up to 70 degrees for half a minute, and then very interesting technology. Also being newly developed and being tested. Those are the technologies, and we've seen all of them being both retrofitted and put on board on new builds on all types of ships. I guess my last comment on my presentation would be that even on new builds or when we are retrofitting a treatment system, it's very important that we don't give this to the yard and then leave, because we are ending up with ships with a very expensive piece of equipment that no one knows how it works or no one knows what's intended to do with. It's important that the superintendent is there following it up, making this link between the operation, which is the crew, this is the whole point, and the installation. We are delaying new builds, we are delivering ships without certificates because this link is not there. We don't know what they want to do with the system, and no one else knows, because the shipyards delivered the ship, they don't want to talk about it, and the crew does not have a clue what is this and how it should be operated. And so my advice when retrofitting on the new builds, put your guys there to follow up this, to understand what's happening, and that will make it much less painful later on. Thank you.
Thank you. Thank you very much, Jad.